Alright, good day guys. Welcome back to GJ's Academy. And our topic for today is indices, but I prefer to call it index notation and function. So what is indices? It's like a method of shortening the product of a number of equal factor or numbers that are the same. May I call it base, or it is called base rather. So without wasting much of our time, this is literally what we are going to be doing today, just the laws of indices with few examples, or one or two examples rather. So the multiplication law here, you apply it when the numbers with equal bases are being multiplied, then you add their power. For example, a to the power of m times a to the power of n. What happens there? We added the power, which is n plus n. Then for example, we are given 3 to the power of 2. For example now, for the multiplication law, you are given 3 to the power of 2 plus 3 to the power of 5. Therefore, answer will be 3 to the power of 2 plus 5, which is 3 to the power of 7. Since we are solving this, so we leave it in the index form. Then for the second law, which is division law, if you have a to the power of m divided by a to the power of n, then you find the difference, or you subtract the powers, which is a to the power of n minus n. So we can use the same example and you can choose to use different example. Okay, let's assume I'm giving 2 to the power of 9 divided by 2 to the power of 6. So of course, you know that this will become 2 to the power of 9 minus 6, which is equal to 2 to the power of 3. Alright, so the next one is power law. So if you are given a variable that is raised to power and they are all bracket and given under power, therefore what you are going to do is you just pick the base and multiply both powers, especially if it is this one. So this is what I'm talking about. If you are given 2 to the power of 2 in brackets, then all together power of 3, then it will be 2 to the power of 2 times 3, which is 2 to the power of 6. Why is it like that? So let me quickly do a quick explanation. So 2 to the power of 2 in 3 places is the same thing as saying 2 to the power of 2 times 2 to the power of 2. So if you apply multiplication here, it will be 2 to the power of 2 plus 2 plus 2 equals to 2 to the power of 6. As you can see, instead of going through this process, so you just break it down like this. So this is the same thing as a times b to the power of 2. So I did it to make it easier. Therefore, this is equal to what? It will be a to the power of 2 times b to the power of 2. So you can also say it is a squared b squared. That's really all about. Or for example, we are giving something like this: 3pq to the power of 2. Of course, you know this is 3 square p square, q square, p square. So it will be, the answer will be 9p square q square. Then the next one is what? 0 index. Of course, you know anything raised to the power of 0 will give us 1. But why is it like that? For example, we are given 2 to the power of 3 divided by 2 to the power of 3. You know it's the same thing as saying 2 to the power of 3. And if you cancel this will give us 1. Alright. So remember, if you apply a division law, this is 2 to the power of 3. If following the law divided by 3, this will give us 2 to the power of 0. So that's how we got the get to know that anything raised to the power of 0 will give us 1. Hope you are clear on that. Note, I won't take much of your time today. So as for the negative index, whenever I say a base raised to the power of negative, it will always be 1 over the same number to the power, first to the power of 1. So let me give you an example. We are given 3 to the power of minus 2. This will be 1 over 3 to the power of 2. That's all. So that's all about negative index. So without wasting much of your time, let's go to the root power. 1 over 2 means square root. The power of 1 over 3 is cube root. The power of 1 over 4 is cube root. So, but alright, let me explain that. I'll explain it in the next law, which is the final one. So we are given 4 to the power of 1 over 2, or 16 to the power of 1 over 2. This is the same thing as saying square root of 4. The same thing as saying square root of 16, which will give us 2, which will give us 4. Same thing goes for cube root. Cube root of what? Let us give us 8. This is how it will look like. So what times what will give us 8? That's 2. So answer is 2. So that is that about root power. Then as for this, the final one for today, which is fraction index. When you have a to the power of m over n, the n, which is the denominator, is usually the root. If you know that in our root power, is usually the denominator is usually the root. So n will be the root, then m becomes the power. Yeah. So n is the denominator is what? The root, then the numerator is the power. For example, we are given 4 to the power of 3 over 2. So remember, 2 is what? Square root. Although you can also break it down like this. Over 1 over 2. Of course, we know that this is square root of 4. Then 3. So that is 2 to the power of 3 equals to 8. Or you can just go straight to the point by saying square root of 4, so to the power of 3. Of course, this becomes 2 to the power of 3 equals to 8. Hope you guys understand. Let me quickly give you one more example. 8 to the power of 4 over 3. So this will be cube root of 8, or in the power of what? 4. And cube root of 8 is what? 2. That's 2 to the power of 4 equals to what? 16. So that's all for today. I just want you to understand the law of indices. Kindly like and subscribe and turn on the notification bell. See you in our next class.